There's no need to get tenser. Relax with Flux Condenser. Subscribe, baby, subscribe.
Hey guys, just a video here trying to see what's going on with my Dynakit Stereo 70 amplifier. This is a kit that I built a while ago, and I've had it in service for a few months now, listening to it on a weekly basis. And recently it's been blowing fuses. There's a 3 amp slow blow fuse in the back here. And what's happening is upon startup, as soon as the filaments heat up, the fuse is blowing. I suspect the problem is with the rectifier tube. Common problem with these amps. The rectifier tubes don't tend to last more than a year or so. So what we're going to do is we're going to open this up. We're going to check the rectifier tube on the tube tester. And we're also going to attempt to replace the tube with a solid state tube replacement, a rectifier tube replacement by Weber. And basically this will plug into the socket where the rectifier goes. And this is just a bunch of diodes inside to replace the simple rectifier circuit tube. This will provide a little more juice. Hopefully that won't cause additional problems. We'll need to rebias the amp. First thing though, let's open it up, check the tube. If it's whatever it reads, I'm gonna try this regardless, and we'll just see if we can get this working. Okay, here we go. There are, I believe, just 4 screws here. To remove the outer cage. Let's see. Now, if you're not familiar with the ST-70, this amp design goes back, I believe, to the late 50s. And I also believe it is considered the most popular tube amplifier of all time. And it's a good design. It provides a good 35 watts per channel. Sound for me has been phenomenal. And it was available, Dynakit, this is Dyna Audio, and I believe most of the products were available as kits. You probably could have also bought it purchased, but most of these, if you'll find on eBay or whatever, have already been built. So the quality can really fluctuate. I built this one myself, so I know the quality is good. And this is actually from a company that had, let's see, this is some of the material that came with it. Sound Values. This is a brochure catalog from the late 80s. And they had, I think they had bought a lot of the old Dyna Audio equipment and kits and things like that. And they had started reissuing their own version of the Dynakit Stereo, which I think the one that I have is actually original. It's the same as the original components. As you can imagine, there's a lot of different ways that you can modify this amp, and there are various kits you can buy to change the circuit, whatever. But this one is pretty original to the original design. Let's see now. Get this cage open here. It's been over a year since I built this, so I can't recall if there were more. Yeah, I think that's it. Just the cage slides in. Almost there. Okay, let me put this somewhere safe. So yeah, as I was saying, this kit that I purchased, I think was actually sold. I have the receipt here somewhere. Where is it? Here it is. So this I purchased this unbuilt as an unbuilt kit off of eBay, and the original purchaser bought the kit in July 13th of 1990. So somebody bought it with the intention of building it, never did, and I ended up with it a couple of years ago. And I never did a video on the build of this, but I have it all documented, so I may put one together showing how it was constructed, and I think I had to replace a few components that had gone bad over the years. I can't recall exactly. Okay, so our rectifier tube obviously is this guy right here. Okay, and okay, it's a 5AR4, and yeah, I believe the tube that came with this also was bad, the rectifier tube, and it was also blowing tubes. I purchased this one from the tube store, and I'm pretty sure it's also getting flaky at this point. So again, what we can do is let's put this on the tube tester, see if it detects anything. But then the hope will be to actually replace it with this WS1T. Weber has various models of rectifier tube replacements with solid state. Some have excuse me, have resistors in them. They're a little bit taller to sort of mimic the actual voltage and power coming out of a tube, because there's a little bit more loss there, obviously, than with the silicon. They recommended, though, for hi-fi amps to purchase this one, which doesn't do that, so there's no drop on the voltage. So again, hopefully the circuit will handle it. We can bring it up slowly on the Variac. Okay. Let's see. All right, let's shift our attention now over to the tube tester. Okay, and let's see. This is a 5AR4 tube, which is also similar equivalent to a G tube, the GZ34. So we can probably do that. Let me just see if the tube tester has the 5AR4 listed as well, because I do think they're interchangeable, but let's see. I see the G. I have the GZ34 here for the Dynakit tube tester, but let's see if we have also the 5AR4. We'll go through our booklet here. And we're looking for tubes with a 5-volt filament voltage, 5AF, 5AR4. Let's see if the specs are the settings are the same. I've got a 53310. Yeah, 53310. So you can use either setting. 5AR4. So we're going to use the socket 33, which is here. Okay. And we're going to put our settings on to, obviously, 5 volts for the filament. And our sensitivity will be set to 10. Okay. Let's let that warm up. Turn the light off there and see if we're getting. Filament is warming up. All right, so I think the first thing we do is we check for live test. I'm going to check for shorts. And we have this section of the tube tester on. no shorts. Okay. And we're going to hit test 1. And it says it's good. Try it with the live test. Also good. All right, so it's not detecting any faults, but as I recall, that was the case with the rectifier that came with this that was also blowing tubes. So something's going, if it's, as I suspect, something's going on in this tube that's causing some intermittent problems. So let's just turn this off for now, leave that there. All right, so let's plug in our WS1T. Okay. All right, so I'm going to hook it up to the variac and maybe also to the current limiter with the dim bulb. We'll start it up slowly. I'm not going to at this point hook it up to an amp and listen to it. We're just going to turn it on and see if the fuse doesn't blow. So we'll also need a fuse here. I think I took this one out. And that is a 3 amp slow blow. And let's see, let me grab one of those. Bear with me while I find, okay, here we go. 3 amp slow blow. I'm not sure. You can't see the variac frame here, so let me see if I can bring that into view a little bit. Let's see, are we in? Okay, yeah, we're just in. This variac, I've shown this before in a few videos. And I've gotten a lot of feedback from people insisting that this is not an isolation transformer, that it's just a variac. I've had to, in the comments, sort of debate with people a little bit. And I just want to assure everybody that this is indeed not only a variac with variable AC, but also an isolation transformer, which is important. Now, yes, most devices that look like this classic variac shape made by variac, are not isolation transformers. But I assure you again, they do have models which have isolation transformers in them. Okay, so as you can see here, if you can read that, isolated. Okay. Okay. Let's plug the, turn this off. That. Turn the amp to on. Okay, here we go. If you can see, can you see that? Yeah, okay. And let's slowly bring it up. Let me turn the lights off so you can see if the filaments are glowing in this. Okay, we're just over 90 volts. 100 volts. No shorts detected. I need to check one thing. I'm going to back off because there is an on-off switch on this, and I may have it on the off position. Nope, I did. That is in the on position. Okay, let's start again. Let's bring it up to 100 and see if we get some some filament action here. Ah, all right, I'm gonna start again. All right, this current limiter, I built in an on-off switch and I forgot to put it on the on position. Let's try again. Okay, glow, it's going back a little bit. Okay. Just about 90 volts. Okay. 95 volts. Okay, we have filaments. Okay. Let's bring it up. 100. This is a 100-watt bulb in the current limiter, which might, it's burning pretty brightly. A little low for this amp for sure. But let's just be on the safe side for now. And geez, it looks, oh, okay. The filaments are still lit. Yeah, okay. All right. Good sign. Let's back off now and let's try it without the current limiter. So we're going to plug the amp directly into the variac isolation. Turn that back on. We're back at 0 volts. Let's bring it up. $90 volts. We have filaments. 100. Okay, seems good. Let's bring it up to full 117. The voltage here can get above over 120. So let's just try it there and see if we can hold without blowing a fuse. Give it a couple of minutes. All right, so if this holds and we don't blow the tubes, doesn't necessarily mean that this is going to work for us long term. But if we can get this to hold for a couple of minutes, what we'll do then is we'll rebias the tubes here it's going to need to be rebiased because we're going to get more current coming through with the solid state rectifier. And I'll show you how to do that as well. This amp makes it pretty easy. We'll get out the manual and review the procedure. But you can do it just with the multimeter and these two pots here. Okay, while I'm doing that, let me review the procedure for biasing the ST-70. All right, the procedure for that will be, we're going to look for, we're still holding, good sign. We're going to look for 1.56 volts at the test point, okay? And those points are accessible from the front panel. These old sockets were used because, again, this design goes back to the late 50s when the preamplifiers were actually, some of them did not have their own power supplies, and you could use the power supply from the amplifier to provide power for the preamplifier. I believe that's how it worked. I've never used one like that. And these sockets here would provide power. These now, I believe the way it's wired, it could still work in that capacity, but it also provides the test point voltage, which makes it easy. So let me get the voltage meter out. Ideally, when you would bias this you would let the amp warm up for a good 30 minutes or so. But let's just see where we're at, see how far off we are. What I'll probably do also is we'll remove it from the variac just to make sure we're working on typical house current. But this is in the approximate range. Okay, well, good sign, it's holding. Let's see if it's getting warm or not. Yeah, not too bad. Not warm at all. Okay. All right, so we're going to use pin 8. You can't see this, but on the front, it shows you that pin 8 bias set points to it, and it says bias set 1.56 volts for the left channel and 1.56 volts for the right channel. And we just need to ground to chassis. Let me get a clip for that. Let's see, what's the best way? Probably the ground point in the back. Yeah, let's use one of these commons for the speaker. Okay, we'll get a quick reading, see where we are. Doesn't matter if you use the left or the right, the common's common, so that's the ground. And let's see, this over here. DC volts, can you see that okay? Yeah. Okay, again, we're looking for 1.56. Let's go over to the right. This probe, let's see, I don't know if it's long enough to get in there. Yeah. The probe's not that great as far as reaching in. But yeah, we're a little on the hot side. Okay, let me just turn these down a bit. As expected, we're a little on the hot side. Let me turn them down, and I'm going to turn the amp off. And hopefully when we turn it back on again, we won't blow a fuse. But yeah, so far I'm encouraged. This might just work out. Which would mean I won't have to keep opening this thing up every 6 months to a year to replace a tube. Just want to see if I have a better... to put something in that pin to so I can probe it more easily. I just got a piece of wire. Okay, I'm just going to strip a piece of bare wire here. By the way, this Strip-Ax Pro 6, these things are phenomenal. What a work saver for stripping wires. It just works brilliantly. Highly recommended. Cut a little piece off here, and I think what we'll do is we'll just take the wire and we'll sort of bend it like that. See if we can get a good fit in there. There's one. Let's try another one. Again, I'm just trying to give myself a better connection point to the socket so we can measure this voltage. want to lose it in there. I don't feel like opening up the whole thing to retrieve a piece of bare wire. Well, let's try that. Okay. And let me replace this with a clip. Okay. All right, so we're not going to use the variac this time. We'll turn that off. We are plugged directly into the house mains. Let's go ahead. Let's flip the switch, and hopefully we don't blow a fuse. Okay. I'm going to turn the lights off real quick, just so you can see the filaments glowing. Okay. Okay, there we go. You may not be able to see that. Yeah, not too well. But yeah, what I'm seeing, I don't think you can see it in the camera, but the tubes are all glowing, the filaments are glowing. Okay. All right, let's check out our bias. Let's go to the left one here. Connect our point. And we have pretty close, 1.6. And again, we're looking for 1.56. And we're going to use our left potentiometer here to bias the left channel. Okay. We'll just get it roughly in range, and we'll continue to let it warm up. Let's go check the right channel now. Real hot. There we go. All right. Okay, as we let that warm up, let me just read the procedure from the manual for this. You might find it interesting. The procedure for setting the bias is to measure the voltage output of a D-type dry cell and note the meter reading. Then insert the positive meter probe in the pin 8 hole of the left preamplifier power socket. Note that the outside chassis, the pin numbers are counted counterclockwise from keyway, while inside the chassis they are counted clockwise. The negative meter probe should touch the chassis. So what they're recommending is just checking the accuracy of your meter by checking a fresh D cell, which would also read approximately 1.56. I don't think that's necessary here with this fluke. This is very accurate, so we can skip that. Then it says plug in the GZ34 rectifier tube, and in about 10 seconds there will be a current flow, which will cause a meter deflection. As the rectifier warms up, the reading will increase. The left bias potentiometer should be adjusted until the meter reading at pin 8 is the same as across the dry cell. This reading will be 1.56 volts if the meter is of sufficient accuracy. This adjustment should then be made using the right bias potentiometer and measuring the voltage at pin 8 of the right power takeoff socket. Then repeat the setting for left control and left set of tubes. There may be some drifting of the reading as the tubes heat, but this will stabilize within 15 minutes, after which no further adjustment is required. So 15 minutes they're recommending for warm-up. Small variations will occur with line voltage changes. These will have no effect on performance. Although the setting is a semi-permanent one, at times of tube replacement or similar repair or maintenance work, Resetting of the bias will preserve peak performance and keep distortion at an absolute minimum. So yeah, of course you want to check the bias from time to time. I'm guessing that by using the solid state, the need for that would be minimized as well, because you're not compensating for the change in the tube. So seems pretty clear to me that, yeah, that tube, even though it's measuring faulty, the rectifier tube is problematic for these amplifiers. So far, the WS1/T seems to be working. I can't guarantee it's going to be a long-term solution, but as of now, it seems to be working just fine. If I have any problems in the future, I'll let you guys know. But so far, so good. I'm going to continue to let this warm up, and I'll continue biasing it and put it back together, and I'll put it in service. And maybe I'll just check in real quick on the video to assure you that everything's working after a couple of hours of playing. Okay, check out for now. Well, good news, the ST-70 has been working well, and I've had it running now for a couple of hours, hasn't blown a fuse. So yeah, it looks like the solid state tube rectifier is going to work out well, which is great news. Again, if anything changes in the future, I'll let you know. But if you're looking for a solution to blowing fuses on a Dynakit Stereo 70, I think that might just work out for you, as it seems to be for me. Just a quick look here at some antique equipment that I've added to my collection right now. We're listening to an old Pioneer deck that I restored. The ST-70 is right now configured to work with the C22 Macintosh preamplifier, which I've restored. I've also restored the MI3 maximum performance indicator, which is an interesting piece of equipment. And as yet, I still have to do the MR71, which is an FM tuner, and this bad boy MC2105 Macintosh solid state amp. A couple other things in the collection: an old Ampex cassette deck that I restored, an old realistic amplifier, which I think I've shown you before quickly on a video, which I've repaired many times now. It's starting to act up again, so I'm gonna have to be opening that up soon. Anyway, just a few other things, just to give you an idea of the kind of things you might see in my channel coming up. Right now, let me show you what I'm working on. Let's go in the other room here. This is, oh, by the way, this is kind of an interesting room. This is my the gym in my house, and it's also being used as sort of an antique stereo sort of room for me to hold my collection. And yeah, so as I'm working out, I listen to a lot of the old equipment and the old speakers. You can see I've got a pair of old KLH Model 6s here, old pair of original Klipsch Fortes, which again you may be seeing coming up. But let's go in the other room here. And oh, actually the one's right here. Turn the lights on in the hallway. Okay, here we have a pair of Ohm Walsh 2s, but no ordinary Ohm Walsh 2s. These, I purchased these on eBay these are circa 1982. The Ohm Walsh 2s, very interesting transmission line type speaker. Lusted over these as a kid, finally got a pair. But I've been doing something interesting to them, and you might, I'm not gonna give it away now, but by looking at this, it might give you an idea. Let me pull the top off. Give you an idea as to what it is I'm doing. Okay, let me just show you real quick. Go in my other room here. A couple of other interesting pieces to the Ohm Walsh speakers. And here's one that I'm working on right now. Yeah, so again, very interesting speakers. I think you'd be very interested in what I'm doing right now to sort of update these, and I've got some interesting opinions and some recordings of the actual speaker and its performance that I'll be bringing you hopefully in the next couple of weeks. So look out for that. I think that'll be the next next thing you'll see on my channel, the Ohm Walsh 2s. Thanks for listening. Take care. I'll see you guys soon.